The concept of water-only fasting for extended periods, especially 72 hours, has become popular for its supposed benefits to metabolic health and longevity. This explanation focuses strictly on what scientifically happens inside the brain during such a fast, without promoting or condemning the practice. Under normal conditions, the brain's primary and preferred fuel is glucose derived from carbohydrates. When you eat, blood glucose rises, the pancreas releases insulin, and glucose is shuttled into cells for energy or stored as glycogen in the liver and muscles. During a water-only fast, this glucose supply vanishes. Within the first 12 to 24 hours, glycogen stores are depleted. As glycogen runs out, the body shifts to lipolysis, breaking down stored triglycerides into fatty acids and glycerol. Most cells can use fatty acids directly, but the brain cannot because fatty acids do not efficiently cross the blood-brain barrier. To feed the brain, the liver converts those fatty acids into ketone bodies, mainly beta-hydroxybutyrate or BHB and acetoacetate, producing nutritional ketosis. By around 72 hours, ketones can provide 60 to 70% of the brain's energy, while the remaining glucose comes from gluconeogenesis using glycerol and amino acids. The brain consumes roughly 20% of the body's resting energy, despite being only 2% of body weight. During the initial transition, many experience keto flu symptoms, brain fog, fatigue, irritability due to electrolyte imbalances and metabolic switching. Once fully adapted to ketones, however, numerous people report heightened mental clarity, focus, and improved mood. Ketone bodies, especially BHB, act as signaling molecules that improve mitochondrial function, reduce oxidative stress, and decrease neuroinflammation. Fasting also significantly upregulates brain-derived neurotrophic factor, or BDNF, often called Miracle-Grow for the brain, which supports neurogenesis, synaptic plasticity, learning, and memory, while potentially protecting against Alzheimer's and Parkinson's. Neurotransmitter balance shifts with possible modulation of glutamate, GABA, dopamine, and serotonin pathways, leading to calmer, sustained focus after an early adrenaline surge. Fasting powerfully activates autophagy, the cellular process of clearing damaged proteins and organelles. In neurons, increased autophagy helps prevent toxic debris accumulation linked to neurodegenerative diseases. However, strict water-only fasting introduces serious risks. With zero electrolyte intake, sodium, potassium, magnesium, and calcium are rapidly excreted, especially as insulin drops. This depletion causes headaches, dizziness, muscle cramps, profound fatigue, confusion, heart palpitations, and in extreme cases, seizures or cardiac arrhythmias, symptoms often mistakenly attributed only to keto flu. Psychologically, some experience increased stress, anxiety, or food preoccupation, and the practice can be dangerous for those with eating disorders or certain mental health conditions. After 72 hours of water-only fasting, the brain shows remarkable adaptation, shifting to ketones, boosting BDNF, activating autophagy, and potentially enhancing cognition and neuroprotection. Yet without electrolyte management, the same fast can severely impair neural function. The response is a complex balance of metabolic flexibility, cellular repair, and the critical need to avoid deficiencies, a powerful intervention requiring informed caution.